Hi Coachella, this is the tutorial for using a motor driver. Let's go. This is the basic code for using the motor driver. We're going to use the SparkFun motor driver to control the speed and the direction of the attached motor. First, we're going to define the two direct logic pins and the speed pin, or the PW pin. So 5, 4, and 6 using the constant integer. Then we're going to set all the pins as outputs here using pin mode. Then in the void loop, we're going to drive forward at the full speed by pulling DRA as high and DRB as low while running the full 255 to the PWM to control the speed. Then we're going to delay for 1 second. And then we're going to break the motor by pulling both direction pins to the same state. In this case, we're doing low, but if we used high, both as high, it would be the same thing. And right now the PWM doesn't really matter, but we're going to set it at 0 anyway. Then we're delaying for 1 second. We're then going to change the direction to reverse by flipping the states of the direction pins from their forward state. So now direction A will be low and DRB will be high, and the PWM will be at 150, just a little slower. And then we're going to delay for a second again, and then again we're going to break by setting both of them to low and the PWM to 0, and then wait for 1 more second. This is the Arduino board for the basic code of using the motor drive. So here's the motor drive, and so then this yellow cable here connects the VM or motor power source to 5 volts through this, connected to the positive column here, connecting to this yellow wire here to the 5 volts pin over here. Then as we go down, this yellow wire connects the board, the VCC or the chip voltage, to 3.3 volts by connecting through this wire to the positive column, through this red wire into 3.3 volts. Then the gray cable here is connected to ground on the driver board, and it's grounded through this black wire here, and then again through this black wire. Then this red wire here is attaching the B02, which is the motor B connection, to the motor itself. Right now it's unplugged, so it's not moving. The black wire here is also attached to pin B01 on the motor driver, which is the motor B connection to the motor. And then the gray wire here is grounding the driver again. So then we move to the other side. Here, the red cable right here is attached to the STBY, which is a standby pin, high for board on or low for board off. And the STBY pin has to be either connected to ground or 3.3 volts. Here is connected to 3.3 volts through this red wire here into the 3.3 volts pin over here. The orange wire, this first orange wire here, is attached to the BIN1, which is the direction pin for motor B, and it's attached to pin number 4 here. Focuses, there we go. And then this yellow wire and this middle yellow wire here is attached to BIN2, which is another direction pin 2 for motor B, and it's attached to pin number 5 on the Arduino. And then this final orange wire here is attached to PWMB, which is the PWM signal for controlling the speed of motor B, and that's attached to pin number 6 right here. And then finally the gray cable here is grounding the driver through this black wire, which is grounded over on the Arduino over here. And if we plug it in, it will work in like 2 seconds. You can see running through the code. I attached a piece of tape so it's easier to see the direction. So that's it. This is the modified code for using a motor driver. We're going to use a SparkFun motor driver to decelerate after it switches directions, and while having an LED increase and decrease the blink rate at the same time. So first we're going to define two logic pins, dr_a and drb, and PWM for the speed, and have the constant integer of the LED as 9. Then we're going to set all the pins as output, and start the serial begin at 9600. Then we're going to create local variables for the PWM speed and the delay times for the LED. And then we're going to have the drive forward at speed, and then we're going to have, so we're going to start DRA as high and DRB as low, so it's going to drive forward, and we're going to serial print that it's high and low. And then in order for it to have it accelerate, we're going to use a for statement. So for when the PWM speed is 0 and less than 150, we're going to have it increase. So we're going to have the analog write function to write the PWM speed into the PWM. We're going to print PWM speed equals the speed given up here, and then wait for 250 milliseconds. And then in that, we're going to use an if statement to say if the PWM speed is less than 150, then we're going to use the digital write function to have the LED turn on, and then delay time, and then decrease as the PWM speed increases, and then turn it off, and then delay it for that same time. So the LED will increase in the blink rate. Then we're going to break the motor by pulling both the direction pins to low, and we're printing that out. And then we're going to set, again, have the PWM as 0. We're going to wait for 500 milliseconds, and then we're going to change direction to reverse by flipping the states of the direction pins to low, from low to high. We're going to start the PWM at 150, and then use a serial print that out, and then we're going to use a for statement to have it actually decrease in speed. So when it equals 150 and it's greater than 0, it's going to decrease. So then we're going to use the analog write function to write the PWM speed from up here onto the PWM, print it out on the serial monitor here, and then wait for 250 milliseconds. Within that, we're going to use an if statement here for the LED, saying that if the PWM speed is greater than 0, then the LED will be on high, and we're going to delay for delay time 2, so that starts at 0 here, and it's going to increase the same time that the PWM is increasing. Just print that out. Then we're going to turn the LED off and delay for that same time. We're going to break one more time, digital write, setting them both to low, and again putting the PWM at 0. Print that out one more time, and delay for half a second. We're going to look at the serial monitor as it works on the modified code. So as we can see that it's measuring the PWM speed here and increasing, and the LED is turning on and off. You can see that it's going on quicker by the speed of it scrolling. Then we get to 150, it'll switch directions. So we're going to pause. So when it gets to 150, you'll see that the motor will switch directions, and it'll start decreasing. The speed will start decreasing. We go down, and that's it. So here's the modified Arduino board for the modified code of driving a motor driver. So here we have the motor driver set up the same way as before. All the wires are going to relate as the same before. But now we also have an LED here that the cathode is attached to the ground column here that's grounded by this black wire, and then again by this black wire through here to the ground pin over here, and then it runs through a 100 ohm resistor into this white wire that connects it to the pin number 9, which gives it its voltage. So here we have the motor accelerating, and the LED is also accelerating in the blink rate. We get up faster. If it gets up to about 150, it'll switch directions. It'll brake and then switch directions and then slowly decrease in speed. There we go. You can see the LED is slowing down as well. And yeah. There we go.